Hello, this is the first video in our series of videos for Chapter 18, covering and discussing acids and bases. So let's go ahead and start this chapter off with first defining what an acid and a base are, which has been done previously, okay? So an acid produces H3O plus, the ion hydronium, in water, when it's placed in water. An Arrhenius base, therefore, produces hydroxide. So this is hydronium, and this is hydroxide in water. And that's about it. Okay, that's our starting definition for what an acid is and what a base is. Okay, so acids, when placed in water, generate H3O plus ions, and bases, when placed in water, generate OH minus ions. Okay, so that's our starting definition for acids and bases. And this was likely first learned in high school physical science class, and you definitely discussed this in Chemistry 1510 previously. And so we're returning to this definition for 1520, but we're going to go to a deeper definition of what an acid and base are here very, very soon. So another recap, let's recap what strong and weak electrolytes are. So if you'll remember, right, we could have an ionic compound such as MX, okay? We can have an ionic compound such as MX, and if we place this in water, it will dissociate into a cation and an anion. Okay, this process is known as dissociation. If you remember, for soluble ionic compounds, that is, ionic compounds that are aqueous when dissolved in water, we refer to these as strong electrolytes. Okay, so remember what an electrolyte is. An electrolyte is a substance that produces ions in water. And those ions can conduct a current. And so one of the original tests for detecting if a substance was an electrolyte is that you would dissolve it into water, and then you would use a simple circuit with a light bulb and a battery to see if the light bulb lights up when the two terminals, the two ends of your circuit that is not complete, get placed in the water solution. So we learned that soluble ionic compounds, based on our solubility rules, and thus would be given the state of matter aqueous, AQ, would be considered strong electrolytes, whereas insoluble ionic compounds, that is, in water, they would be given the state of matter as solid because the ions of an insoluble ionic compound want to stick together more than the independent ions want to stick to a shell of water molecules. We would refer to this effectively as a non-electrolyte. Okay, now in terms of covalent compounds, okay, a common species to look at was the acid. Okay, we know acids from our definitions. So if we take an acid and we place it in water, we'll talk about this reaction in more detail in this chapter. What can happen is that acid And actually, let me differentiate this a little bit. We'll use HX right now, okay? Can undergo something called ionization by interacting with the water to form X minus ions and H3O plus ions. Note, this meets the definition of an Arrhenius acid because when placed in water, it produces hydronium ions, right? Now, if it does this to approximately 100%, we would call this not only a strong electrolyte, but a strong acid. That means effectively every molecule of HX has ionized to form an X minus anion and an H3O plus cation, which was formed from the water with the H plus. Now, we could also have an acid react with water, and as has become a theme, it could end up not undergoing total ionization, right? So maybe less than 10% ionization to form A minus, aqueous, plus H3O plus. So for example, HC2H3O2, this acid, known as acetic acid, about approximately 1 out of every 1,000 molecules is ionized at equilibrium. So in this case, ionization is occurring, but since it's so weak, since we get so little ionization, we would call this a weak acid. Now, if you remember, strong acids, you had a list of 5 that you needed to memorize. They are HCl, HBr, HI, HNO3, and H2SO4, first proton only. Because you'll note here, we'll learn this term in a later video, H2SO4 is a polyprotic acid. In other words, it has 2 ionizable protons. The first one comes off very easily and about 100%. So that's a strong acid. The second one is it's harder for it to ionize. And therefore, that's why we note that only the first proton is strongly ionizable. Okay. All other acids. Oh, wait, there was one more. HClO3. HClO4. Perchloric acid. But we tend not to focus on that one. Just pay attention to what the instructor wants to focus on in terms of your strong acids, but definitely memorize these 5, HCl, HBr, HI, HNO3, and the first proton of H2SO4. But there is a 6th strong acid. You'll note it in your book. Perchloric acid, HClO4. All other acids will be considered to be weak acids, okay, for our purposes. Okay, so this was kind of a recap of electrolytes. And this that we just discussed right here is going to be the focus for this chapter. And we will come back to this in the next video.